There's something happening at the back of your skull right now, not pain, not pressure, just activity. The kind that never announces itself, the kind that was already running before you noticed you were noticing. You've probably felt it before, that slip. Not sleep, not memory exactly, something closer to the edge of both. It lasts maybe 2 seconds, maybe less. A room or a sentence someone says, or the specific angle of late light through a half-open door, and suddenly your brain is absolutely certain it has been here before. Not vaguely certain, certain, the way you're certain that today is Tuesday, or that you turned off the stove, except you didn't turn off the stove. You've never been in this room. This sentence has never been said to you. And somewhere in the space between that certainty and that impossibility, you catch yourself, briefly, weirdly suspended, and then it's gone. Welcome to the Sleepy Biologist. This channel stays alive because of the people who come back to it night after night, the members, the supporters, the ones who've left a quiet thank you in the comments when they couldn't sleep. If you're new here, you can stay. If you pressed like somewhere along the way, that matters more than it sounds. And if you've been here long enough to know what this channel is, then you already know that what comes next won't be rushed. What just happened, that 2-second certainty, has a name that most people have said out aloud at least once in their lives. Déjà vu. Already seen. The French phrase is older than the science behind it, and there's something fitting about that. For a long time, the experience floated in the space between dream logic and paranormal explanation. Poets wrote it down. Novelists gave it to their characters. Charles Dickens described it as that strange kind of fancy of having lived through the exact moment before. And he didn't explain it. He just noticed it. That noticing is exactly where good biology tends to begin. It's more common than most people realize. Studies suggest somewhere between 60 and 97% of people report having felt it at some point in their lives. That's almost everyone, which raises something worth sitting with. If this many people experience the same strange sensation, it probably isn't strange at all. It's probably just what a healthy brain does, on occasion, under certain conditions, without telling you. The sensation doesn't come with a warning. It doesn't build. It arrives already fully formed, that conviction of prior experience, and what makes it so peculiar is not just the familiarity. It's the awareness of the familiarity. You don't just feel you've been here before. You also know at the same time that you haven't. Both things are present simultaneously, the knowing and the unknowing sitting side by side in the same moment. That's worth pausing on. Most experiences of recognition don't feel like that. You see a face you know and you know it. You walk into your kitchen and it's familiar and you don't wonder about that. It just is. But in déjà vu, recognition and skepticism arrive together. And that co-arrival is the thing. It's not a feeling of false memory. It's closer to a feeling of disagreement. Two parts of your brain briefly landing on different answers to the same question. Researchers have spent a long time trying to understand which parts of the brain are involved. And they've found them, more or less. Two systems nested inside the temporal lobe, sitting close enough together that they usually work in sync. One handles familiarity, the other handles recollection. Familiarity is the warm hum of prior contact. Recollection is the falsity, where, when, what it felt like, what came after. In most moments, these two systems fire together, and you experience recognition as a single smooth thing. You know the face, and you know the name, and you know the afternoon you met at a party in 2014. It all arrives as one, but occasionally, rarely, briefly, familiarity fires without recollection following. The hum of prior contact without the story, familiar with no content attached, And your brain, which is a fairly good fact checker when it's healthy, immediately notices the problem. It notices that familiarity arrived without evidence. And that noticing, that moment of your own brain flagging an internal inconsistency, is what you feel as déjà vu. It's not a glitch exactly. It's more like catching an error before it spreads. There are a few different theories about what causes the misfiring. The signal that carries familiarity might arrive fractionally early, or it might travel a slightly longer route and arrive twice, the second arrival wearing the same timestamp as the first. Or a new scene might share enough geometry with something stored, the layout of furniture, the angle of a hallway, that partial recognition fires without full recall attaching. None of these explanations is complete. It's not entirely clear which one is most accurate, or whether different instances of déjà vu arise from different causes. There's something we still don't fully understand about why it happens when it does, and not more often, and not less. What the research does point toward fairly steadily is that déjà vu is associated with healthy brain function. Younger brains, which have more excitatory activity, report it more. People who travel frequently, who encounter genuinely new environments and give their pattern recognition system something novel to work with, report it more. People who are tired or distracted report it more, likely because fatigue softens the boundary between familiarity and novelty, letting small mismatches slip through. It shows up in an amplified form in temporal lobe epilepsy, where the circuits involved in familiarity can fire too loudly for too long with nothing to stop them. That version is more intense, harder to shake, not followed by the return to clarity that healthy déjà vu brings. But the tissue is the same tissue. The sensation is recognizably the same sensation. The difference is one of amplitude, not kind, which means the small fleeting version, the one that lasts 2 seconds and leaves a faint residue of wonder, is produced by the same equipment operating within its normal range. Your brain does this sometimes. It checks its own work. It runs familiarity against recollection, finds a mismatch, flags it. The flag is brief, the correction is quiet. You barely know it happened, except for that 2-second slip, that strange vertical drop through a moment that felt already lived. By the time you've registered it, the system has already resolved it. The feeling fades. The room returns to being a new room. The sentence goes back to being the first time it was ever said, and the machinery underneath, the two systems, the familiarity signal, the quiet fact-checking frontal regions, goes on working without asking your permission, without needing your attention, without stopping for the night. It will keep running, actually, all through the dark, in ways that, if you followed them downward, get much stranger and more detailed than a 2-second feeling of familiarity. The structure doing most of this work has been doing it for a very long time. Longer than language, longer than anything you could call memory in the ordinary sense of the word. Before you had words for things, this was already running. Not metaphorically, literally. The structure at the center of all of this, the one that will matter for everything that follows in these next few hours, was doing its work before you could name a single object in a room, before you understood that objects had names, before the concept of a room existed for you at all. It was encoding, tagging, threading one moment to the next with a patience that didn't need you to notice it. There's something quietly strange about that. If you let it land, the hippocampus, that's the name of it. Curved bow, paired, one on each side nested inside the medial temporal lobe, roughly behind each ear. If you press 2 fingertips gently just above and behind your ears right now, you'd be maybe 3 centimeters from it. not touching it, but close enough that the distance feels personal. It's small, about the size and rough shape of a seahorse, which is what the Greek word actually means. Hippo, horse, campus, sea monster. Whoever named it wasn't wrong. There's something ancient-looking about its form, something that belongs in salt water rather than the soft grey tissue of a skull. It doesn't store memories the way a hard drive stores files. That's not quite how it works. It's more that it holds the threading, the connective logic between fragments that are scattered widely across the cortex. A memory of a specific afternoon isn't sitting in the hippocampus as a single retrievable object. It's distributed. The sound is over here, the smell is over there, the emotional weight of it lives somewhere else entirely. The hippocampus is what makes those scattered pieces feel like one thing when they surface, which means the hippocampus isn't really a storage room. It's closer to the logic that tells you the pieces belong together. And it is old, and not old in the way your bones are old, built and rebuilt across a single lifetime, constantly renewing. Old in the way that evolutionary biologists mean when they use the word carefully. The hippocampus, or something structurally recognizable as its ancestor, appears across a huge range of vertebrates. Rats, birds, fish, reptiles. It predates everything that might be called complex thought. It was doing spatial memory long before there were creatures capable of wondering about spatial memory. A salmon uses hippocampal tissue to navigate back to the exact tributary where it was born, not approximately exactly. A bird encodes the precise locations of thousands of cached food items across a landscape and retrieves them months later with accuracy that should feel implausible but doesn't, once you understand the machinery involved. The point is, this tissue has been solving memory problems for a very long time. What it does in you tonight, threading together the scattered residue of your day, quietly deciding what to keep and in what form, is a continuation of something that was already well practiced before your species existed. You're not the first animal to lie still in the dark while a hippocampus worked. You're one in a very long line. There's something in that worth staying with. Not the grandeur of it. I'm not reaching for grandeur here. Just the plainness of it. The fact that this structure, sitting a few centimeters behind your ear, is doing something older than language, older than the kind of self-awareness that would let you find that strange. It doesn't know you're awake right now. Doesn't need to know. It was running before your attention arrived, and it will keep running after your attention dissolves into sleep. It processes spatial information, the layout of rooms you've moved through, the angles of paths, the geometry of scenes encountered and filed. It encodes what researchers call episodic memory, memories bound to specific situations, to when and where and the felt texture of a particular moment. Not general knowledge, not facts learned from a page. The kind of memory that says, I was in a room like this once and the light came in from the left and I was tired in the same way I'm tired now. That kind of memory. The kind that sometimes, when conditions are slightly off, fires just ahead of itself. Outside somewhere, maybe a car, a door. The particular sound a building makes when the temperature drops and its materials contract. Nothing, really. Just the world still running while you start to slow. The hippocampus encodes experience continuously. This is worth saying plainly because it tends to surprise people. It is not a system that switches on when something important happens and switches off otherwise. It is tagging and threading constantly throughout your day, most of it below the level of anything you'd call noticing. The texture of the floor under your feet this morning, the specific ambient sound of the room you ate lunch in, the arrangement of objects on a table you passed without looking at, all of it went somewhere. Not all of it will be kept. The brain is ruthlessly selective about what gets consolidated, what gets strengthened, what gets quietly dissolved. but the initial encoding is near constant. What this means, and here is where déjà vu begins to feel less mysterious if not less strange, is that your brain holds an enormous number of partial records. Sketches really, rather than complete photographs. Fragments of spatial geometry, emotional tone, sensory texture, all loosely organized, waiting for something in a new experience to partially match them. And when a new scene shares enough with one of those fragments, the angle of a hallway, the specific ratio of open space to furniture, the way sound moves in a room with a particular ceiling height, the hippocampus may begin pattern completion before recollection catches up. It fills in the shape of what it thinks it recognizes, and for 2 seconds, or 3, or sometimes just 1, you feel like you have been exactly here before. Not because you have, because the sketch was close enough. There's a subtlety here that I find harder to let go of than most of the science. The hippocampus isn't making an error in the way that word usually implies. Careless, avoidable, correctable with more attention. It's doing exactly what it was built to do. It is pattern completing. It is recognizing partial matches. It is extrapolating from what it knows toward what it encounters. This is, under ordinary circumstances, one of the most useful things a brain can do. Encountering a place that shares geometry with a place where something dangerous happened, and feeling a flicker of recognition before conscious thought has assembled the reason. That is not a flaw in the system. That is the system working. Déjà vu may simply be the rare moment when you are awake enough, and the mismatch is just obvious enough to consciously catch the pattern completion mid-process. Most of the time it happens and you don't notice. You just feel vaguely that you know this place. This structure, small, curved, ancient, tireless, will keep working as you drift. It doesn't sleep the way your muscles sleep, the way your attention sleeps. During certain stages of the night ahead, it will replay fragments of what happened today, compressed, reorganized, stripped of redundancy. It does this every night. It has been doing it in some form for as long as vertebrates have had something resembling a night. What it keeps, and how it keeps it, and what it does with the seams between what is old and what is new, that is where the strange machinery of familiarity is really housed. You already know this feeling, not the science of it, just the feeling itself. The way a place can seem known before you've had time to think about whether you've been there. The way a sentence can feel already said. There's no drama in it usually, no particular fear, just a brief sourceless certainty, and then the slow return of the present tense. What's harder to notice, because it happens below the level of anything you'd call awareness, is that this feeling is being produced by 2 separate processes running in parallel. Not 1, 2. And the reason déjà vu feels the way it does, that specific quality of wrongness layered over rightness, is because those 2 processes are designed to arrive together, and occasionally, briefly, they don't. The first process is familiarity. It's faster than you'd expect. Automatic in a way that the word automatic barely captures. It doesn't deliberate, doesn't assemble evidence, doesn't pause. It simply fires. Something enters your field of experience, and before conscious thought has had time to organize itself into a question, a region of the medial temporal lobe, particularly the Rhinal cortex, a strip of tissue curved around the inner surface of the temporal lobe, has already issued a verdict. Known, or not known. The signal is more like a hum than a statement. A warm, low register that says prior contact without saying when, without saying where, without offering anything you could actually use. Familiarity is context-free. That's the technical description, and I think it's the most accurate one, even if it sounds cold. It doesn't carry a story, it carries only the sensation of having encountered something before, the way you might feel you know a face in a supermarket without being able to locate a single fact about the person. The feeling is real, the content is absent. Both things are true simultaneously, which is, if you sit with it, a genuinely odd design feature of the mind. The second process is recollection. Slower. Much slower, relatively speaking. Recollection involves the hippocampus pulling together the distributed fragments of a stored episode, location, time, sensory detail, emotional texture, and assembling them into something coherent enough to be consciously retrieved. It requires effort in a way that familiarity doesn't. Not effort like lifting something heavy, more like the effort of focusing, of waiting for the full image to develop rather than accepting the blur. Recollection says, I know this face and I know her name is probably something starting with an M, and I think we met at a conference and I was tired that day and she had a red lanyard. Familiarity says, known. Under ordinary circumstances, which is to say under most circumstances, these two processes arrive together. Familiarity fires first and recollection follows close enough behind that the whole thing feels like one experience. You recognize someone, and the recognition includes content. It feels seamless. You'd never know there were two systems involved firing in sequence, unless something went slightly wrong with the sequence, something about that design. I keep coming back to it. The fact that these two processes are separate, that they run on different tissue, serve different functions, operate on different timescales, and yet are meant to feel like one thing. It seems like the kind of arrangement that would produce occasional failures almost as a matter of probability. Not illness, not damage, just the statistical inevitability of two systems that need to synchronize, occasionally not synchronizing, which is one way of understanding déjà vu, not a malfunction, a sync error. The perirhinal cortex, the structure most associated with familiarity, does something specific and worth understanding in its own right. Its neurons respond strongly to novel stimuli. A new face, a new room, a new arrangement of objects. The perirhinal cortex fires with something close to alertness. But as exposure increases, as a stimulus becomes familiar through repeated encounter, those same neurons fire less. The response dampens, the signal quiets. This dampening is, in a functional sense, how familiarity is encoded, not by adding something, but by the gradual reduction of a response that was once strong. It's a strange way to store knowing as the absence of surprise, familiarity as the quieting of a system that was once loud. There's something in that I find unexpectedly honest about how memory works. That recognition at its most cellular level is not brightness, but its opposite. Not a light switching on, but a light that slowly stops flickering. So when the perirhinal cortex fires in the presence of something genuinely new, a room you've never entered, a moment you've never lived, and fires with that quieter, dampened quality associated with familiarity, the rest of the brain receives a signal it has no reason to doubt. Known, it says, and the hippocampus, which should at that point assemble the supporting evidence, the when, the where, the surrounding context, finds nothing. No episode to retrieve, no story that could explain the familiarity, and this is the moment that researchers have spent a surprising amount of effort trying to understand what happens in the gap between familiarity without content and the awareness that the familiarity is wrong. Because that awareness, the second guessing, the recognition of the recognition as impossible, that isn't free. It requires something. Specifically, it requires the frontal regions of the brain to weigh in. to run a check, to compare the familiarity signal against what the hippocampus can actually verify, find a discrepancy, and flag it. And the flagging is what you feel. The hum of a refrigerator maybe, or the particular absence of sound that a room has late at night when everyone else has been asleep for hours. Small things, nothing. What's interesting, and this is the part that tends to get left out of shorter explanations, is that the flagging itself is a sign of healthy function. The frontal cortex is doing error monitoring. It is, in a fairly literal neurological sense, fact-checking. It caught an inconsistency between the familiarity system and the recollection system, and instead of simply accepting the familiarity signal without question, it surfaced the discrepancy to conscious awareness. That surfacing is déjà vu, not the error, the catching of the error. In people with certain kinds of temporal lobe pathology, this check can break down. Familiarity fires, recollection fails, and crucially, the monitoring system doesn't flag the mismatch. The result is persistent false recognition, sometimes debilitating, with no accompanying sense that anything is wrong. The familiarity just feels true. The fact that in healthy déjà vu you know it's wrong, that you can hold both this feels familiar and this cannot be familiar in the same moment, is not incidental. That dual awareness is the system doing what it's supposed to do 2 seconds, maybe 3. The feeling arrives fully formed. The check runs, the discrepancy gets flagged, and then the familiarity signal fades. Because it was never attached to anything, there was nothing to sustain it, and the moment settles back into newness. You've just witnessed your own brain's error correction process from the inside. Most people, when it happens, just think, déjà vu, and move on, which is probably the right response. But the machinery underneath that 2-second bloop, the separate systems, the sync delay, the frontal monitoring, the check against evidence, that machinery is running continuously. In you right now, in everyone around you, in brains that have been doing this in one form or another for a very long time. The peripheral cortex is quiet at this hour, dampened. You're not encountering much that's new. Things around you are known, or near enough to known that the familiarity signal barely has to work, which is actually one of the gentler things a brain can offer you at the end of a day. The gradual quieting of the system that registers surprise, the slow cessation of novelty, and underneath that, deeper, older, still threading and tagging in the dark, the structure that holds the stories the familiarity signal can't tell on its own. Every scene you move through today went somewhere, not in the way people sometimes imagine, not as a clean recording, not as footage that could be rewound and inspected. More like a signal that got separated into its components mid-transmission and sent to different addresses. The colour and shape of things went one direction. The emotional register of the moment went another. The spatial layout, where the door was relative to the window, how far the table sat from the wall, went somewhere else again. And the hippocampus, sitting in the middle of all of this, was doing the threading. Quietly, without asking you for help. This happens continuously. It was happening this morning while you were thinking about something else entirely. What the hippocampus actually does, in the mechanistic sense, is this. It receives converging input from an enormous range of cortical areas, sensory cortices, association areas, the regions that process emotion, the regions that handle spatial orientation, and it binds the co-occurring elements of an experience into something that can later be retrieved as a coherent episode. The binding isn't storage in the conventional sense. It's more like the hippocampus holds the index. The key that, when activated during later retrieval, sends a signal back out to all those distributed cortical regions simultaneously, causing them to reactivate together. producing something that feels like remembering. The fragments themselves live in the cortex. The hippocampus holds the logic that makes them cohere. There are people, and I find this genuinely hard to sit with, who have lost hippocampal function entirely. The most documented case in neuroscience, a man known for decades simply as HM, had large portions of both hippocampi removed in 1953 as a treatment for severe epilepsy. He lived for another 55 years. He could hold a conversation. He recognized faces he'd known before the surgery. His personality remained largely intact, his intelligence measurably preserved. But he could not form a new episodic memory. Every new person he met was a stranger again. Every time. Every room he walked into was, to him, a room he'd never entered. He once described his experience as waking from a dream, always continuously waking from a dream, never accumulating a present. He was not unhappy, by most accounts, but the case made something undeniable. Without hippocampal function, the ordinary continuous threading of a life stops. The day does not build. Each moment stands alone. What the hippocampus threads specifically is episodic memory, and this distinction matters more than it might seem. Episodic memory is bound to context. It carries when, where, how it felt. It is different from semantic memory, which is general knowledge, facts untethered from the circumstances in which they were learned. You know that a refrigerator keeps things cold, that's semantic. You remember the specific afternoon you first noticed that the refrigerator in a childhood kitchen hummed differently depending on the weather, that's episodic. The hippocampus is essential for the second kind, less involved in the first. The implication, what you retain of today, in the deep sense, is not information. It's situated experience. The bare facts will probably survive in some form, but the texture of this evening, the particular tiredness, the specific quality of quiet, the temperature of the room, that situated residue depends on hippocampal encoding, and hippocampal encoding depends, more than most people realize, on what happens in the next several hours. Somewhere between your toes and the mattress there is a specific pressure, small, probably unnoticed until just now. Inside the hippocampus, there are subfields, regions with distinct cellular architectures and distinct functional roles. CA3, a dense recurrent network, is thought to be where pattern completion happens, the process by which a partial cue triggers the retrieval of a whole stored representation. CA1 acts as a comparator, checking incoming information against stored patterns, flagging mismatches. The dentate gyrus does something called pattern separation. It takes inputs that are similar and makes them more distinct from each other in neural representation, preventing memories from blending together when they share features. These three subregions work as a system. Feed a partial cue into CA3 and it attempts completion. Send the completed pattern to CA1 and it checks it. If the match is clean, retrieval proceeds smoothly. If the match is imperfect, if what's incoming doesn't quite align with what's stored, something gets flagged. The flagging is familiar. It's the same check that surfaces as déjà vu. Here is the part that I keep getting stuck on though. The hippocampus encodes not just what happened, but where. Place cells. Neurons in the hippocampus that fire specifically when an animal occupies a particular location in space were one of the landmark discoveries of late 20th century neuroscience. John O'Keefe, who won the Nobel Prize for this work in 2014, found that certain hippocampal neurons behave like internal GPS coordinates. A rat in a maze develops a map in its hippocampus, each place cell corresponding to a specific location, the whole population of cells forming something like a neural chart of the environment. In humans, this system is more abstract, more flexible, spatial in a broad sense that includes not just physical location, but context, situation, the relational geometry of a scene. When you enter a room, your hippocampal place cells fire in patterns that reflect not just where you are, but the whole spatial arrangement of the environment around you. The furniture distribution, the ceiling height, the distance between objects, all of it encoded in firing patterns, more detailed than you'd ever consciously notice. This is why spatial resemblance, a new room that shares enough geometry with an old room, can trigger partial recognition. The place cell pattern partially overlaps. CA3 attempts completion, and suddenly the room feels known before it has any right to. So an ordinary afternoon is, at the hippocampal level, an extraordinarily busy one. Every room, every hallway, every conversation whose emotional texture was distinct enough from the last one, every face encountered, every arrangement of objects, every moment of mild surprise or mild comfort, all of it being encoded, threaded, indexed. The vast majority of it will not survive consolidation. Tonight, during sleep, the hippocampus will replay fragments of what happened, compressed, reorganized, stripped of redundancy, and large portions of today will dissolve. Not lost in a way that should distress you. Dissolved because the brain is selective, because selectivity is what makes the system work, because a memory system that kept everything with equal fidelity would not be a better memory system, it would be a slower one. What remains after that process, cleaner, more efficiently stored, shifted gradually toward cortical networks that don't require the hippocampus to retrieve them, is something closer to the skeleton of experience. The gist, the pattern extracted from the noise. And here's the thing about patterns. The more efficiently your hippocampus has encoded the geometry of past experiences, the more accurate and distinct its spatial and contextual representations, the more precisely the familiarity and recollection systems can do their work. A well-encoded memory provides a clear template for comparison. A poorly encoded one provides a smudged one. And smudged templates produce more false matches, more partial recognitions that aren't quite right, more moments when CA3 completes a pattern that shouldn't be completed, when the familiarity signal fires on insufficient evidence, which is one reason fatigue increases déjà vu frequency. Not because tiredness makes the brain more mystical, because a tired hippocampus encodes less cleanly. The representations blur slightly at the edges, and slightly blurred representations produce slightly more false completions. The brain isn't more poetic when you're exhausted, it's just less precise. All of this is happening right now, though more quietly than it was this afternoon. The inputs have slowed, the scenes have stopped changing. What remains is whatever is already in process. Fragments being threaded, representations being held loosely before tonight's consolidation makes its selections. The hippocampus doesn't announce what it keeps. It doesn't consult you. It works with what it was given, applies criteria you had no part in designing. And by morning, something that was vivid will have become either solid or gone. There's something in that, not troubling exactly, more like a reminder that the self is partly downstream of processes it never gets to supervise. The threading happens anyway, the indices form anyway, and somewhere in the CA, 3 of each hippocampus, patterns are completing quietly in the dark, matching fragments of today against fragments of every day before it, finding resemblances no one will ever consciously notice most of the time. Something reaches you, a room, a voice, the quality of light in a particular corner. It enters through the usual routes, eyes, ears, the whole sensory apparatus doing what it always does, and begins its journey inward, toward the regions that will process it, sort it, file it somewhere or discard it. This part is ordinary. It happens thousands of times a day without producing any feeling worth noticing. But occasionally the signal takes two routes, and the second one is slightly slower than the first. This is one of the older theories about déjà vu, and I want to be honest that it remains contested, not disproven, but not settled either. The basic idea goes like this. Incoming sensory information reaches the brain along multiple pathways simultaneously. Under normal conditions, these pathways deliver their signals with enough overlap in timing that the brain processes them as one unified event. One arrival, one moment, clean. But if one pathway is delayed, even by milliseconds, even by a margin too small to mean anything by ordinary standards, the brain may process the signal twice in quick succession. The second arrival, fractionally late, is interpreted not as a continuation of the first, but as a separate event. Something already processed. Something, in other words, already experienced. The brain timestamps its inputs. That's not a metaphor. It's closer to a functional description of how temporal cortex handles the sequencing of perception. And if the same input receives two timestamps close enough together but not identical, the second one reads as prior. Already seen. A researcher named Robert Efron proposed something along these lines in 1963. He suggested that the left temporal lobe receives information twice, once directly, once after a brief detour through the right hemisphere. Normally the detour is short enough that the two arrivals feel like one, but stretch that detour by a fraction, and the second arrival lands wearing the wrong timestamp. Not now, but before. It's a tidy hypothesis, almost too tidy, which may be why it has never quite satisfied everyone who's looked at it carefully. The brain is not in general a tidy system. The pathways don't sort that cleanly, the timing isn't that simple, and there are features of déjà vu, the spatial recognition component, the specific involvement of the Rhinal cortex, the fact that it can be induced by direct electrical stimulation of very particular brain regions that a pure timing delay model struggles to account for. Still, the core intuition behind it is not wrong. Perception is not instantaneous. That sentence sounds obvious, but it keeps having implications that surprise people. The unified moment you experienced, the room, the voice, the light, all arriving together as a coherent now, is a construction. A synthesis assembled by the brain from signals that traveled different distances at different speeds and arrived with slight offsets that are corrected, smoothed over, edited into the feeling of simultaneity. The now you experience is actually a few hundred milliseconds in the past. The brain works slightly behind the present and then presents the result as current. This is normal. This is always happening. Déjà vu might be one of the rare occasions when the smoothing fails just barely enough to notice. There's also a related possibility, not identical to Efron's model but adjacent to it. Rather than a delay in a peripheral sensory pathways, the disruption might occur higher up in the processing itself. Two cortical systems handling the same incoming scene, one slightly ahead of the other. The familiarity system, of faster, more automatic, processes the scene and issues its verdict before the full perceptual and contextual processing has completed. So the scene arrives in conscious awareness already pre-tagged as familiar, even though the evidence for that familiarity hasn't been assembled yet. Familiar before understood, known before examined. What all of these variants share, the timing delay, the pathway split, the processing asynchrony, is the idea that the brain's sense of temporal order is more fragile than it seems, that the felt boundary between now and before is not a fixed wall, but something constructed freshly, continuously, from signals that don't always arrive in perfect synchrony. Most of the time the construction is seamless, you never notice the editing. And then occasionally for 2 seconds the edit doesn't quite close, and you catch a glimpse of the seam, the place where the brain stitched now and already together, and got the stitch slightly wrong. The contested part, and it's worth leaving this unresolved rather than papering over it, is whether the timing delay is the primary cause of déjà vu in most people, or whether it's one mechanism among several, operating sometimes and not others. Researchers who work specifically on the Rhinal cortex tend to emphasize the familiarity system misfiring. Researchers focused on perceptual processing tend to emphasize the timing and pathway models. There is, as yet, no clean consensus, which is honestly where a lot of neuroscience actually lives, not in settled answers, but in competing partial explanations, each of which accounts for some of the data and struggles with the rest. The brain produces this feeling. That much is agreed. The exact route it takes to get there is still being worked out. What's clear enough is that the signal, however it arrives, by whatever route, with whatever small displacement of timing, eventually reaches the regions that matter. The temporal lobe, the rhinal cortex, the hippocampus waiting to supply context that, in this case, it cannot supply. And somewhere in that gap between signal and context, between the hum of familiarity and the absence of any retrievable story, the feeling assembles itself, brief, sourceless, certain, gone before you finished noticing it. The brain is not one thing. It's easy to speak of it as though it were a unified organ with a single disposition, doing its work in some vague interior space. But the tissue itself, if you could examine it without the pressure of hurry, reveals something more like a landscape than a machine. Ridges and valleys, regions that fold back on themselves, layers of different cellular architecture stacked in columns, each column handling a narrow slice of experience, communicating laterally and vertically through connections so numerous that any single attempt to count them collapses into abstraction. Somewhere in the range of 100 trillion synapses, a number that means nothing until you stop trying to picture it and just accept that the brain is structurally almost incomprehensibly interconnected. A scene enters this landscape and spreads, not everywhere at once. It travels along established routes, activates particular regions in a rough sequence, gathers meaning as it moves. The visual cortex handles the raw geometry. The temporal cortex begins assembling identity and context. The parahippocampal gyrus, a long fold of cortex wrapping around the inner surface of the temporal lobe, close to the hippocampus but distinct from it, starts processing the spatial configuration, the layout, the relational arrangement of elements in the scene. And the rhinal cortex, which sits at the edge of all of this, acts as something like a gatekeeper between the cortical processing systems and the hippocampal memory system proper. All of this in fractions of a second. All of this without a single conscious decision on your part. The rhinal cortex deserves more attention than it usually gets in popular descriptions of memory. It has 2 parts, the entorhinal cortex and the perirhinal cortex, and together they form the primary interface between the neocortex and the hippocampus. Almost everything the hippocampus knows about the current moment has passed through the rhinal cortex first. It is, in a functional sense, the last stop before memory, the place where the fully processed, fully assembled representation of a scene arrives before the hippocampus decides what to do with it. What the rhinal cortex does with that representation is not simply relay it. It compares it. It holds the incoming scene against stored patterns, assessing familiarity in a way that is faster and cruder than full hippocampal recollection. Not do I have a memory of this, but does this feel like something I've processed before? A rough triage, a first pass, and the signal it generates, that initial familiarity assessment, travels both toward the hippocampus and toward conscious awareness, which is why familiarity can surface before recollection has had time to assemble anything coherent. Two destinations, the same signal, sent simultaneously. Here is what researchers found when they began placing electrodes, carefully, in patients who are already undergoing pre-surgical evaluation for temporal lobe epilepsy inside the rhinal cortex. They could induce déjà vu. Not reliably, not in every patient, not with every stimulus. But when electrical current was delivered to the entorhinal or perirhinal cortex at the right intensity, in the right location, a significant proportion of patients reported the distinct sensation of inappropriate familiarity, the feeling of déjà vu, without any corresponding environmental trigger. No new scene, no partial spatial match, just tissue being stimulated, and the feeling assembling itself from nothing. The hippocampus stimulated directly produced different effects, sometimes vivid recollective experiences, sometimes emotional responses, sometimes nothing remarkable at all. But déjà vu was more readily produced from the rhinal cortex than from anywhere else. This matters more than it might initially seem. If déjà vu could be induced by stimulating a specific region, that meant it wasn't a vague global brain state. It had an address, a relatively precise one. But there was a complication, and it's the kind of complication that makes the science more interesting rather than less. Stimulating the rhinal cortex alone was not always sufficient. In some patients, déjà vu occurred only when the stimulation was followed by a particular pattern of electrical synchrony between the rhinal cortex and the hippocampus, a rhythmic coupling in the theta frequency range, a synchronization of activity across the two structures that suggested they were briefly talking to each other in an unusual way, which shifted the picture somewhat. Déjà vu wasn't purely a rhinal cortex phenomenon, it was a network phenomenon, something that emerged from the relationship between rhinal cortex and hippocampus, from their communication, or more precisely, from a specific kind of miscommunication. The rhinal cortex issuing a familiarity signal, the hippocampus receiving it, attempting to verify it, finding no supporting content, and the whole network oscillating in that particular frequency that surfaces the discrepancy to awareness. The feeling arises in the gap between two structures that are trying, briefly and unsuccessfully, to agree. There's a quality of late-night air that is different from daytime air in a way that's hard to name. Denser maybe, or just quieter in a way that makes the body feel more present to itself. The weight of your own limbs, the particular stillness of a face doing nothing. The cortical columns that process incoming scenes are arranged in a hierarchy of complexity. Early visual areas handle orientation and contrast. Higher areas handle object identity, scene category, spatial relationships. At the top of the hierarchy, in the regions directly feeding into the rhinal cortex, the representations are extraordinarily abstract. Not a chair at a particular angle in particular light, but something more like the concept of a chair in a spatial context, stripped of most of its perceptual specificity. This abstraction is what allows the familiarity system to find partial matches across experiences that don't look obviously similar. Two rooms that share spatial layout but differ entirely in decor, lighting and occupants can produce overlapping representations at the level of abstract spatial processing. The columns that encode the geometry are the same columns firing in both cases, producing similar activation patterns, generating similar familiarity signals. The brain isn't being imprecise when this happens, it's being appropriately abstract. The abstraction is the point, it's what allows generalization, transfer, the application of past experience to new situations. Déjà vu is, in this light, a side effect of a feature. The cost of a system sophisticated enough to recognize similarity beneath surface difference. What strikes me most, having spent time with this research, and I realize this is a fairly personal response to what is technically just neuroscience, is the sheer extent of the network involved. The cortical columns, the parahippocampal gyrus, the rhinal cortex, the hippocampus proper, the frontal monitoring regions. A fleeting 2-second feeling of inappropriate familiarity is the surface expression of activity distributed across an enormous tract of brain tissue, involving multiple distinct processing stages, multiple distinct memory systems, a precise kind of interregional communication that has to occur within a specific frequency range to produce the effect at all. It is not a simple thing that happens to you. It is an extraordinarily complex thing, which is perhaps why it remains only partially understood despite decades of careful work. And it lasts 2 seconds, sometimes less. By now the cortex is quieter than it was an hour ago. The scenes have stopped arriving. The parahippocampal gyrus has less spatial geometry to process. The rhinal cortex is receiving less, comparing less, sending fewer familiarity signals upstream and downstream. The columns are still active. The brain at rest is not the brain silent, but the particular kind of activity that produces the sense of familiarity requires incoming novelty, requires something new to assess. There isn't much new right now, which is in its own way a form of relief the nervous system doesn't have a word for, the gradual withdrawal of novelty, the slowdown of the comparison engine, the rhinal cortex settling into something lower and quieter as the night deepens. The network that generates déjà vu is going still, not off, just no longer being asked to check. Most of what your brain does, you never feel. Synapses strengthening, neurotransmitters clearing from the cleft, the constant recalibration of threshold potentials across millions of neurons, adjusting, resetting, preparing for the next signal. The hippocampus threading together the residue of the afternoon, the cerebellum making tiny corrections to muscle tone even now, even while you lie still, maintaining a kind of postural readiness that never fully switches off. None of this surfaces. None of it has a texture you can report. The machinery runs entirely below the level of anything that could be called experience, and you go about your life and your nights completely insulated from the vast majority of what your nervous system is doing, which makes déjà vu unusual. Not because it's dramatic, it isn't particularly. Not because it's strange in the way that hallucinations are strange, where something appears that shouldn't be there, where the boundary between internal and external blurs in unsettling ways. Déjà vu doesn't do that. Reality testing remains intact throughout. You don't believe the room is familiar. You feel it is familiar, while simultaneously knowing it isn't, and that gap between feeling and knowing stays open and legible the whole time. The feeling doesn't overwhelm the knowledge. Both simply coexist, briefly, in a way that most cognitive events don't allow. What makes it unusual is that it briefly makes the machinery visible. Most memory processes are invisible by design. Familiarity assessments happen continuously. Every face, every room, every voice runs through some version of the comparison engine in the rhinal cortex without ever producing a sensation you'd notice. The assessment runs, the signal is issued, behavior adjusts accordingly, and none of it reaches the level of felt experience. You walk into your own kitchen, and it doesn't feel familiar in any noteworthy way. It just is familiar, in the same unremarkable way that the word "e" is familiar. Not producing any response worth naming, just processed and passed over. The déjà vu moment is different because the comparison engine produces an output that conflicts with something else. With the recollection system's inability to find supporting evidence, with the frontal monitoring regions that catch the discrepancy and surface it. The conflict is what makes the process conscious. Without the conflict, there is nothing to notice. The familiarity signal fires and dissipates, leaving no trace in experience. With the conflict, the signal gets escalated, reviewed, held up to the light, and for 2 seconds, you feel the system checking itself. That's genuinely rare. There are other moments when the brain's own processing becomes briefly perceptible, the tip of the tongue state where you can almost feel the retrieval mechanism straining toward a word it can't quite reach, the sense of a forgotten dream hovering just at the edge of recall, clearly present and clearly inaccessible at the same time. These are moments when the gap between process and awareness narrows enough that the process itself becomes part of the experience. Déjà vu belongs to this category. It's a metacognitive event, which is a technical way of saying that you are, in some limited sense, experiencing your own cognition rather than simply enacting it. You're not just recognizing, you're noticing that you are recognizing, and simultaneously noticing that the recognition has no legitimate basis. And both of these awarenesses are present together without cancelling each other out. This requires something. It requires the kind of monitoring that simpler cognitive architectures don't have. The frontal regions, particularly the medial prefrontal cortex and anterior cingulate cortex, are involved in this monitoring. They are the parts of the brain that watch the other parts, that compare ongoing experience against expectation, that flag inconsistencies rather than simply absorbing them. Animals with less developed frontal monitoring systems may experience the misfiring, the familiarity signal without recollective support, but probably do not experience the metacognitive layer, the awareness of the misfiring, the sense that something is wrong with the recognition itself. That layer, as far as we can tell, requires a brain complex enough to model its own states, which is not a claim about uniqueness or superiority, just an observation about complexity and what it costs and what it occasionally produces as a byproduct. One of the things it produces, apparently, is this: a 2-second window in which you briefly perceive the inner workings of your own memory system, notice that something is slightly off, and then watch the system correct itself in real time. You've probably had the experience of catching yourself mid-assumption, believing something for a moment, then recognizing the belief as unfounded, then releasing it. The whole sequence happening fast enough that it barely registers as a sequence, more like a small internal adjustment, a flicker of self-correction that leaves no particular residue. Déjà vu has a similar structure. The familiarity is issued. The monitoring system catches it. The correction runs, the feeling fades. The residue is just the faint awareness that something briefly didn't match, and the equally faint awareness that the brain noticed. What's different is that in déjà vu, both ends of the sequence are felt simultaneously. You don't first believe and then correct. You believe and doubt at the same time, in the same moment, without one displacing the other. That simultaneity is its particular texture, the thing that makes it feel strange even when you understand intellectually what it is. The frontal regions that perform this monitoring are also, not coincidentally, the regions that tend to be more active and more excitatory in younger brains, which is part of why younger people report déjà vu more frequently. Not because their memory is worse, in most respects it isn't, but because their error monitoring systems are more sensitive, more responsive, quicker to escalate a mismatch to conscious awareness. The monitoring is vigorous enough to catch small discrepancies that an older, slightly less reactive frontal system might simply absorb without comment. This is, depending on how you look at it, either a feature of youth or an early form of something that quiets down with age. The brain eventually learns, if that's the right word, to let small inconsistencies pass without surfacing them, which produces fewer déjà vu experiences, which also possibly produces slightly less accurate self-monitoring overall. The trade-off isn't clean. It remains, in the end, a feeling that most people have had and few can fully describe, not because it's ineffable, but because it's vast, and because the describing tends to arrive after the thing itself has already resolved. You reach for language and find the moment already closed. The machinery went back underground. The comparison engine is running again, below the threshold of awareness, where it usually lives, assessing, flagging, resolving, producing no sensation worth naming. Most of what your brain does you never feel. There is a threshold in the brain where incoming experience meets stored history. Not a metaphorical threshold, an anatomical one, or close enough to anatomical that the distinction barely matters. The Rhinal cortex sits at the boundary between the neocortex and the hippocampal memory system, receiving the fully processed output of sensory and association cortices and passing it inward toward the hippocampus. Everything the hippocampus knows about the current moment has, with very few exceptions, travelled through this tissue first. It is the last organised stop before memory, the place where the assembled representation of a scene, stripped of most of its raw sensory detail, elevated to something more abstract and relational, arrives for a final assessment before being handed over to a system that will decide what to do with it permanently. 2 centimeters of cortex, roughly, folded into the inner surface of the temporal lobe, doing something the brain cannot easily do without it. The Rhinal cortex has 2 subdivisions that are worth holding separately for a moment. The perirhinal cortex occupies the anterior portion, closer to the front, and handles familiarity assessment for objects and items. It is the region most directly associated with that stripped, context-free signal of prior contact, the known that arrives without a story. The entorhinal cortex occupies the posterior portion and serves as the primary gateway to the hippocampus itself, the main corridor through which information passes in both directions, into the hippocampus during encoding and back out during retrieval. They work together. They are not the same thing, and the distinction matters for déjà vu because the perirhinal cortex specifically appears to be where the misfiring originates, or at least where it is most easily triggered. Stimulation studies in epilepsy patients, where electrodes placed directly in brain tissue allow researchers to activate small regions with precise electrical current, have shown this with unusual clarity. Stimulate the perirhinal cortex at the right location and intensity, and a meaningful proportion of patients report the distinctive sensation of inappropriate familiarity, not a vivid memory, not an emotional siege, just that hum of prior contact without content, the feeling, sourceless and certain, of having been here before. Stimulate the hippocampus directly and you get something different, richer sometimes, more narrative, occasionally a fragment of what feels like actual recollection, a scene rather than a sensation. The hippocampus, when stimulated, reaches for story. The perirhinal cortex, when stimulated, reaches for recognition. The difference between those 2 outputs, recognition and recollection, is the difference between the 2 systems the previous chapters have been circling. What happens when the perirhinal cortex is damaged or removed tells a complementary story, and in some ways a more precise one. There is a surgical case, a young woman referred to in the literature as patient NB, who underwent removal of a large section of the left perirhinal cortex as treatment for intractable temporal lobe epilepsy. Her hippocampus was spared, her recollection remained intact, but her familiarity was selectively impaired. She could recall specific episodes in detail, where she had been, what had happened, the contextual fabric of her own past, but the automatic hum of prior contact was gone. Things that should have felt simply unremarkably known required her to consciously reconstruct why they were known. The familiarity signal had been the silent background noise of ordinary recognition, and she had lost it. Her case provided what had been, to that point, a missing piece, evidence that familiarity and recollection are not just conceptually separable, but anatomically separable, that they can be individually damaged while the other remains largely functional, that they are genuinely distinct systems running in parallel rather than one system with two aspects, the particular softness of a blanket against an arm, not information, just texture, just the specific give of fabric under a small amount of pressure, the kind of thing the brain registers without comment. The perirenal cortex, under normal circumstances, does something elegant. Its neurons respond most strongly to novel stimuli. A face never seen before, a room never entered, the perirenal cortex fires with something close to alertness, a robust response that says, in cellular terms, this is new. As the stimulus becomes familiar through repeated exposure, that response gradually dampens. The neurons fire less, the signal quiets. Familiarity, at this cellular level, is encoded as the progressive reduction of a response that was once loud. Knowing, in a measurable neurological sense, is the accumulation of quiet, which means the familiarity signal that reaches awareness during déjà vu is, at its origin, a misfiring of this dampening mechanism, the perirenal cortex responding to a genuinely novel stimulus with the quieter, dampened pattern associated with prior exposure, not recognizing something real, misclassifying something new as something old based on a pattern match that is partial coincidental, a product of shared spatial or featural overlap rather than actual prior encounter. The signal is generated, it travels toward consciousness, and the hippocampus, asked to supply the supporting context, finds nothing. There is a detail in the stimulation research that tends to stay with me longer than most of the other findings. In patients with temporal lobe epilepsy whose seizures involve the rhinal cortex, déjà vu frequently appears as part of the pre-seizure aura, the cluster of sensations that precede and announce the onset of a seizure. In these patients, the déjà vu can be prolonged, sometimes lasting minutes rather than seconds, and intensely convincing in a way that healthy déjà vu is not. The sense of familiarity becomes absolute, not just a hum, but a roar. The awareness that the familiarity is inappropriate, the metacognitive check that makes healthy déjà vu feel strange rather than simply true, can sometimes be overwhelmed by the sheer amplitude of the signal. Researchers found that stimulation of the rhinal cortex produced déjà vu more reliably and more purely than stimulation of the hippocampus. But they also found something more specific. Déjà vu appeared most consistently when stimulation of the rhinal cortex was followed by a particular pattern of theta frequency synchronization between the rhinal cortex and the hippocampus. The feeling required not just rhinal cortex activity, but a specific dialogue between the rhinal cortex and hippocampus, a synchronized conversation that, in this context, carried false information. The rhinal cortex sending a familiarity signal it had no grounds to send, the hippocampus receiving it, attempting verification, finding nothing. The two structures briefly locked in a conversation that couldn't resolve, and the feeling arising in that gap, in the space between what was asserted and what could be confirmed, What this suggests about the nature of the experience is that déjà vu is not simply an error in one region. It is a network failure, or more precisely, a network miscommunication. The Rhinal cortex generates the initial misfire. But the full phenomenology of déjà vu, the particular texture of it, the simultaneous familiarity and wrongness, the awareness of the conflict, requires the hippocampus to receive that signal, attempt to honor it, and fail. And it requires the frontal monitoring regions to catch the failure. 3 structures, at minimum, 3 separate states, all of it unfolding in under 3 seconds, producing a feeling so brief and sourceless that most people, having had it, can barely describe what happened. The perihynal cortex is quiet now, receiving little, comparing little, generating almost no familiarity signals because there is almost nothing new arriving. The room is known. The dark is known. The specific quality of stillness at this hour is, by now, simply familiar. The kind of familiar that never surfaces to awareness because it meets no resistance, conflicts with nothing, requires no checking. The threshold is there. The doorway between experience and memory, between incoming and stored, between the new and the already known. It just isn't being asked to make many decisions right now, which is, in its way, the best condition for the next several hours of what the brain has to do. Something the next chapter will get to, though not quite yet. There is a version of déjà vu that lasts minutes, not 2 seconds. Not the brief, sourceless slip that resolves before you've finished registering it. Minutes, sustained, intensifying, carrying a quality of absolute conviction that the healthy version never quite reaches. People who experience this describe it differently than the ordinary kind. It doesn't feel like a quirk of perception. It doesn't produce that characteristic double awareness. The simultaneous knowing and doubting that makes healthy déjà vu feel strange rather than simply true. In the prolonged version, the familiarity doesn't feel misplaced. It feels correct, overwhelmingly, unquestionably correct, as though every detail of the current moment, the room, the conversation, the specific quality of light, had already been lived through, and the present was simply a faithful repetition of something that had already, definitively, occurred. This is what déjà vu looks like in temporal lobe epilepsy, where it appears as part of the seizure aura, the cluster of sensory and cognitive experiences that can precede and announce a seizure's onset. And it was precisely this clinical observation, noted and documented across decades of neurology, that first pointed researchers toward the temporal lobe as the origin of the phenomenon, not in healthy brains initially, in sick ones, in tissue that was misfiring in ways that were measurable, mappable, reproducible. Temporal lobe epilepsy, TLE, involves seizures that originate in or near the temporal lobe, often in the medial structures, the hippocampus, the amygdala, the rhinal cortex. The seizures can be brief or extended, can involve loss of awareness or can spare it entirely, and are often preceded by auras that are distinct enough to be diagnostically useful. Some patients report sudden fear. Some report an unusual smell, specific and hard to describe. Some report a dreamlike dissociation from their surroundings, and a significant proportion report déjà vu. Not occasionally, repeatedly, predictably, as a reliable harbinger of what is about to happen neurologically. The same feeling that healthy people experience as a fleeting oddity becomes, in TLE patients, a warning signal, something to note, to act on, a biological alarm that the temporal lobe is about to produce a seizure. What this means anatomically is that the tissue generating ordinary déjà vu in healthy brains and the tissue generating the prolonged, intensely convincing déjà vu of TLE aura is the same tissue. The rhinal cortex, the hippocampus, the medial temporal lobe structures whose role in familiarity and memory has been traced through decades of careful research. The difference between the healthy experience and the pathological one is not a difference in mechanism or location. It is a difference in amplitude. The signal is louder. Loud enough in TLE that the metacognitive check, the frontal monitoring system that catches the mismatch and surfaces the wrongness, cannot keep up. The familiarity signal overwhelms the error correction mechanism. The awareness that something is wrong gets drowned out by the sheer force of the feeling that something is known. Wilder Penfield understood some of this before the cellular mechanisms were mapped. In the 1950s, working with epilepsy patients undergoing awake brain surgery, a procedure in which the patient remains conscious so that language and memory areas can be identified and avoided, Penfield used electrical stimulation to probe the temporal cortex. He found, to his considerable interest, that stimulating certain regions could reliably produce what he called experiential responses, vivid, specific, sometimes overwhelming sensations of familiarity, or fragments of apparent memory, or dreamlike states that patients described with unusual precision and conviction. He was careful not to overclaim. He noted that these stimulation-induced experiences differed from normal memory in specific ways. They ran forward, couldn't be voluntarily controlled, and vanished immediately when the current stopped. But the key observation was undeniable. Here was brain tissue that, when activated abnormally, produced the subjective experience of recognition and memory. And in TLE patients whose seizures originated in this same tissue, that recognition, déjà vu, appeared as a natural consequence of the abnormal activation. There is a tentative finding worth mentioning here, though it should be held lightly. Some research has suggested a possible role for dopamine in déjà vu experiences, particularly in the context of TLE. Elevated dopamine levels have been detected in rodent models of temporal lobe epilepsy, and there is speculation, not yet well established, still carefully contested, that excess dopamine in the limbic system may contribute to the generation of inappropriate familiarity signals. It is a hypothesis that fits plausibly with what is known about dopamine's role in salience and reward prediction, its tendency to mark things as significant, to generate the feeling that something matters. Whether it has a clear role in the non-pathological déjà vu of healthy brains is even less certain. I mention it because the research exists, not because the picture is clear. It isn't. What is clearer, and this is the finding that I think matters most for understanding the healthy experience, is what happens to recognition memory in TLE patients who experience déjà vu as part of their seizure aura, compared to TLE patients who don't. When researchers gave both groups formal memory tests designed to separately measure familiarity and recollection, a consistent pattern emerged. Patients whose TLE included déjà vu showed selective impairment in familiarity. The automatic hum of prior contact was unreliable, dysregulated, firing when it shouldn't. Their recollection was largely preserved. They could retrieve episodes, assemble context, reconstruct the when and where of past experience. But the familiarity signal had become noisy, and crucially, the déjà vu required both. It required the noisy familiarity signal, yes, but it also required the intact recollection system, the functioning hippocampus, to receive that signal and attempt to verify it, and fail. If recollection were also severely impaired, there would be nothing to oppose the false familiarity, no check, no mismatch, no déjà vu, just persistent, unchallenged false recognition. The experience of déjà vu, even in its pathological form, requires a brain that is still capable of doubting itself. It rained somewhere earlier tonight. That particular smell that comes through a window that's been left slightly open, not unpleasant, just present. There is something uncomfortable about sitting with this material, and I think it's worth acknowledging rather than smoothing over. The tissue that produces a strange and mostly harmless 2-second feeling of misplaced familiarity in healthy brains is the same tissue that, when it misfires in a more sustained and disordered way, can signal the onset of a seizure. The machinery is the same. The experience differs in degree and in the presence or absence of the metacognitive check, not in fundamental mechanism. This isn't cause for alarm. It is genuinely just anatomy. The brain's systems exist on spectrums, their healthy operation shading continuously into their disordered operation, with no clear wall separating normal from pathological, just gradations of amplitude and duration, and the presence or absence of compensatory mechanisms. Healthy déjà vu is brief, because the misfiring is small. The signal is weak enough that the error correction system catches it quickly. The familiarity fades because there is nothing sustaining it. No ongoing seizure activity, no runaway synchronization in the Rhinal hippocampal network, just a small spurious signal that the brain notices, flags, and clears. What remains after it clears is just the ordinary present. The room as it actually is, the moment as it actually is, new and known to be new and no longer pretending otherwise. The temporal lobe, quiet again, doing its work below the level of anything that surfaces to awareness, as it does almost always, almost all of the time. Here is something worth considering before sleep makes considering difficult. Your brain has been in thousands of rooms. Not just rooms you remember being in, rooms you passed through, glanced into, registered peripherally while your attention was elsewhere. Waiting rooms, corridors in buildings you visited once for reasons you've since forgotten, the interior of a friend's car, a restaurant corner, a hallway in a hospital or a school or an airport, moving through it with no particular intention of keeping it, and yet the hippocampus encoding it anyway. The spatial geometry, the proportions, the rough relationship between ceiling height and floor area, the placement of doors relative to windows. Filed somewhere. Not prominently, not with any flag indicating that this particular layout would ever matter. Most of it never does, but occasionally, and this is where the geometry becomes interesting, a new room shares enough of its spatial logic with one of those filed layouts that something trips. Not a full match, a partial one. Enough overlap in the proportions, the arrangement, the abstract relational structure of the space that the pattern matching system begins its completion before recollection has a chance to establish whether there's actually anything to complete. The idea has an old nebnidal name, Gestalt familiarity. Gestalt in the sense that the psychologists of the early 20th century used it. The whole, the configuration, the total arrangement rather than any individual element. The hypothesis in its basic form is this. Déjà vu can occur when the spatial layout of a new scene matches the spatial layout of a previously experienced scene stored in memory, even when that previous scene cannot be consciously recalled. It's not about the furniture, it's about where the furniture is. Not the specific objects in a room, but the geometry they collectively produce. The distances between things, the ratios of open space to occupied space, the directional flow that a particular arrangement creates. Two rooms can be entirely different in every visible detail and still share enough of their underlying spatial logic that the brain's pattern recognition system finds the overlap before the conscious mind has registered anything unusual. And the unrecalled memory, the room from the waiting area in a building visited years ago, the corner of a restaurant glimpsed from across the street, doesn't need to surface for its geometry to do its work. It just needs to be similar enough, close enough. A partial match is sufficient to generate the signal. A psychologist named Anne Cleary at Colorado State University spent years building a laboratory version of this, which is harder than it sounds. Déjà vu is notoriously resistant to controlled study, appearing spontaneously and vanishing before anyone can measure it, refusing to perform on demand. Cleary's approach was indirect and, in retrospect, fairly elegant. She used virtual reality to create immersive three-dimensional scenes. For each scene, she built a second scene that was entirely different in its visible content. Different objects, different colours, different surfaces, but identical or near identical in its spatial configuration. The same underlying geometry dressed in completely different clothing. Participants moved through the first scene with no particular instruction. Later they moved through the second scene, the one they hadn't seen, the one that shared only the layout, not the appearance, and they reported it. Familiarity. Déjà vu. The specific combination of recognition and wrongness that distinguishes the experience from ordinary familiarity. The feeling arrived more reliably when the spatial configuration matched and its intensity scaled with the degree of overlap. More similar geometry, more déjà vu, less similar geometry, less. The geometry was doing it, not the content, not any consciously traceable similarity. The abstract spatial structure, processed in the parahippocampal gyrus and passed to the Rhinal cortex, generating a familiarity signal from a template the conscious mind had no access to. This is, when you sit with it, a slightly vertiginous finding. It means that your brain is holding spatial templates of places you have no deliberate memory of visiting, comparing new environments against those templates automatically and continuously, and occasionally finding a match strong enough to surface as felt experience without ever telling you what the match is, or where the original template came from, or that this process is happening at all. You are, without knowing it, a walking archive of geometries. Every room you've ever passed through has contributed something to a spatial library that your brain consults silently every time you enter a new space. Most consultations produce nothing. The new space is different enough, or the stored templates are too degraded to register a hit. But sometimes the proportions are close. Sometimes the flow of a hallway into a larger space, or the specific ratio of window to wall, or the placement of a threshold at a particular angle. Sometimes these coincide closely enough with something already filed, and the filing system quietly announces known. What Cleary was careful to note, and I think this matters, is that spatial resemblance is probably one cause among several, not the whole explanation. Déjà vu can occur in enclosed spaces with no particular geometric complexity. It can occur during a conversation, triggered by a phrase or a sequence of sounds rather than a visual layout. It can occur in people who are not moving through space at all, lying still in a room they know well, triggered by something that has nothing to do with spatial configuration. The Gestalt hypothesis accounts for a meaningful portion of cases. It doesn't account for all of them, and Cleary herself was explicit about this. The research was evidence that spatial resemblance can produce the experience, not evidence that it always does, which leaves the picture a little unresolved in the way that accurate scientific pictures often are. Several mechanisms, each of which is real, each of which operates under different conditions, each of which produces what feels from the inside like the same experience even though the underlying trigger differs. The feeling is the same, the roots to it are multiple. There's also something worth noting about the unrecalled memory at the center of all of this. The room whose geometry matched. The spatial template that generated the familiarity signal. It's still in there somewhere. Degraded, inaccessible to deliberate retrieval, but present enough to have participated in a pattern match. The memory didn't disappear. It just became unreachable through the ordinary pathways of voluntary recall, while remaining available to the automatic systems that never stopped consulting it. Cleary described this plainly, and it has stayed with me. The fact that something fails to be recalled doesn't mean it isn't still present. Often it is. Often the memory exists in some residual form, too faint or too poorly encoded for deliberate retrieval, but carrying enough structural information to influence recognition from below the surface. Déjà vu in this reading is not your brain inventing familiarity from nothing. It's your brain detecting a real similarity that you simply cannot trace back to its source. The signal is, in a narrow technical sense, legitimate. The geometry genuinely overlapped. The problem is only that the source cannot be identified, so the familiarity arrives without a story, without context, without the name of the room or the year or the building or the afternoon. You move through it without looking. The body adjusts position without being asked. A small shift. The automatic maintenance of comfort that continues even as attention begins to soften. There is something almost reassuring about this, once the initial strangeness settles. The idea that your brain is not malfunctioning when déjà vu occurs, that it is in fact detecting something real, performing a valid pattern match, reporting a genuine structural similarity that exists in the world. The error is not in the detection. The error is only in the attribution. The brain cannot identify the source, so it generates the feeling of familiarity without attaching it to anything specific, leaving you with recognition that has no object, which is honestly a fairly precise description of how much of memory actually works, not as explicit, retrievable, fully contextual episodes, but as residue, structural traces, influences on present processing that operate without announcing themselves, shaping the feeling of a moment without offering any account of where the shaping came from. Most of memory is invisible. Déjà vu is one of the rare occasions when its invisibility briefly partially fails, when the residue surfaces just far enough to be felt without surfacing far enough to be understood. The room you're in right now is being encoded, not prominently, not with any particular priority, but the geometry is being noted somewhere. The spatial logic filed in whatever form the parahippocampal system uses for these things, added to the archive that's been accumulating since you were old enough to move through space. Someday, in a room you haven't entered yet, it might be the template that generates the match. You won't know which room it was. You'll just feel, briefly, that you've been there before. Something is already beginning, not dramatically, not with any signal you'd notice. But the biology of the night has started its work. The slow withdrawal of certain neurotransmitters, the gradual shift in the brain's electrical patterns, the body's temperature beginning its quiet descent. These changes don't wait for sleep to be complete. They begin at the edges of wakefulness, in the softening of attention, in the way sounds set from outside arrive now with less urgency than they did an hour ago. The brain is already preparing the conditions it needs. What it needs tonight is to consolidate what today left behind. Everything you encountered today, every room, every face, every fragment of conversation, every moment of mild surprise or mild comfort was encoded in some preliminary form. The hippocampus was doing its threading throughout, building indices, holding the connective logic between fragments distributed across the cortex. But encoding is not consolidation. Coding is the first pass, the rough draft. The representation exists, but it is labile, unstable, vulnerable, not yet woven into the longer fabric of what you know and how you know it. Consolidation is what happens next, and it happens predominantly here. in the dark and in sleep. The idea that sleep serves memory is not new. People have suspected it for as long as people have noticed that a night of sleep tends to clarify what the day left murky. But the mechanisms behind it have only become visible relatively recently, as recording technology became fine enough to track the electrical activity of specific brain regions across the night. What that technology revealed was not the brain going quiet during sleep. It revealed the brain doing something extraordinarily organized. The night divides into stages, not rigidly. The architecture shifts across the hours, the proportions change, the sequence is more variable than early models suggested. But in broad terms, periods of deep non-REM sleep, called slow-wave sleep, alternate with periods of REM sleep. Each has a distinct electrical signature. Each does something different with the memories the day produced. During slow-wave sleep, the brain generates a particular pattern of coordinated activity. Slow oscillations in the cortex, sleep spindles produced by the thalamus, and brief high-frequency bursts of activity in the hippocampus called sharp wave ripples. These three don't just coexist, they couple. The timing of each is influenced by the others. The sharp wave ripples tend to nest within the excitable phase of the cortical slow oscillations, and the spindles bridge them. The whole arrangement is a mechanism, a precisely timed biological mechanism for transferring information from the hippocampus outward to the cortex. What happens during a sharp wave ripple is this. A large population of hippocampal neurons fires in a sudden, highly synchronized burst, and within that burst, the neurons replay. In compressed form, sometimes 20 times faster than real time. The sequence of activity that occurred during a waking experience. The room you moved through this morning, the conversation, the geometry of an unfamiliar space that the parahippocampal gyrus encoded without telling you. The hippocampus plays it back, not as experience, as electrical pattern, as a signal sent outward to the cortical regions that hold the distributed fragments of that memory, nudging them toward each other, strengthening the connections between them, making the whole representation slightly more coherent, slightly more stable, slightly more retrievable. This happens hundreds of times in a single night. Each ripple is brief, 40 to 100 milliseconds. A flicker. But the flickers accumulate, and their accumulation is the mechanism by which the day's experiences are selected, strengthened, and gradually transferred from hippocampal indices to cortical storage. By morning, the memories that survived this process will be more stable than they were at bedtime, less dependent on the hippocampus for retrieval, more woven into the broader network of what you know. The ones that didn't survive will be gone, not erased in some violent sense, just not strengthened, left to degrade. The hippocampus is ruthlessly selective about which patterns it replays. Novelty, emotional salience, experiences that were tagged during waking as consequential, these get more replays, more reinforcement. The ordinary and the peripheral get fewer, and many of them will not make it to morning in any retrievable form. There is a word for what the hippocampus does during replay that I find more accurate than replay itself: reactivation. The memory is not simply played back like a recording, it is reactivated. The neural pattern is re-expressed, the connections are re-engaged, and each re-engagement slightly modifies what is stored. Memory consolidation is not preservation, it is reconstruction. Each replay is also a subtle revision, which has an implication for the familiarity system, a memory that has been consolidated, replayed multiple times, transferred to cortical storage, its internal connections strengthened and made more precise, provides a cleaner template for the pattern matching operations that produce déjà vu. The spatial geometry is encoded more faithfully. The abstract representation held by the parahippocampal gyrus is sharper, more distinct. The template is less blurry at the edges, a memory that was never properly consolidated, or was consolidated under conditions of fatigue or disruption, one that exists as a smeared, imprecise representation, provides a worse template. Its edges bleed into neighboring representations. Its pattern match threshold is lower, meaning it fires on less evidence, meaning false matches become more likely. Sleep doesn't just consolidate memories for the sake of remembering them. It consolidates them in a form that makes the memory systems more accurate, and more accurate memory systems produce fewer false familiarity signals. Or rather, they produce the same false signals, but the error correction mechanism has cleaner material to work with and catches them more reliably. The relationship between sleep quality and déjà vu is not perfectly mapped in the research. Not yet, but the emerging picture is coherent. Sleep deprivation blurs memory representations, softens the boundaries between stored patterns, and reduces the precision of the familiarity recollection system. The result is a brain more prone to partial matches, more likely to find false similarities, less equipped to quickly resolve the conflict when familiarity fires without legitimate cause. Fatigue doesn't make the brain more mystical, it makes it sloppier. And sloppy pattern matching produces more déjà vu, not as a gift, but as a symptom of reduced precision. The fleeting, wonder-tinged experience of déjà vu in a well-rested brain is a different thing, biologically, from the more frequent and less charming version that arrives on the back of too many consecutive poor nights. After slow-wave sleep, REM arrives. The brain's electrical activity shifts. Slower oscillations give way to something faster, more mixed, closer to waking in its frequency profile. The hippocampus enters a different mode. The sharp wave ripples quiet. Theta oscillations emerge instead, rhythmic, slower, associated in waking animals with active exploration and learning. During REM, the consolidation process continues but changes character. Where slow-wave sleep seems to handle the strengthening and transfer of specific episodic memories, REM sleep appears to be involved in something more integrative, finding connections between newly consolidated memories and older ones, extracting patterns, building schemas. The abstract spatial templates that contribute to Gestalt familiarity, the general knowledge of room geometry and scene configuration that accumulates across a lifetime, this kind of integrated schematic knowledge may be particularly shaped by REM sleep processing. It is during REM that the brain may be most actively building the library of spatial and contextual patterns that the parahippocampal gyrus will consult tomorrow, and the day after, and every day until the library is large enough and precise enough that most new rooms feel new in the right way, recognizably novel, not confusingly familiar. Outside something, difficult to say what. A shift in the quality of the dark, maybe. The particular stillness that arrives in the hours before the night tips toward morning. The sharp wave ripples are already running now, or close to it, in whatever stage of early sleep you've settled into. Small, brief, hundreds of times through the night, the hippocampus playing back fragments of today in compressed electrical shorthand, the rooms, the conversations, the faces, the geometry of spaces you pass through without intending to remember them. Some of what today contained will be there by morning, strengthened, clarified, shifted toward cortical storage where it will persist without much further help from the hippocampus. Some of it will be gone, the peripheral details, the redundant fragments, the experiences that were too similar to too many previous experiences to warrant their own stable representation, absorbed into the general pattern, contributing to the template without surviving as individual episodes. And the templates themselves, the spatial libraries, the abstract geometries, the accumulated record of where walls tend to be and how rooms tend to flow, will be incrementally refined, slightly more accurate than yesterday, slightly more precise in the matches they draw and the mismatches they flag, which means that tonight's sleep is not separate from the déjà vu you may have felt this week, or the one you might feel next month. It is continuous with it. The quality of the consolidation happening right now, the precision of the replay, the faithfulness of the transfer, is one of the biological conditions that determines whether the familiarity system will work cleanly in the days ahead, or loosely, or somewhere in between. The brain is doing its maintenance. It does this every night. It has always done this. And you are, at this particular moment, one of the more cooperative conditions it requires. Still, quiet, letting the temperature drop, letting the oscillations begin their slow organized work. The hippocampus doesn't need you to do anything, it just needs you to stay. Forgetting is not what most people think it is. The common intuition that memory is a container, that forgetting means the container has a leak, that a better brain would lose less, is almost exactly backwards. Forgetting is not the failure mode of the memory system. It is, in large part, the memory system working correctly. The brain does not forget because it runs out of space, or because the trace was too faint, or because something went wrong in the encoding. It forgets because forgetting is one of the things it was built to do, deliberately, at the level of individual synaptic connections, through mechanisms as specific and as regulated as any other biological process. This is worth sitting with, because it changes the relationship between sleep and memory in a way that matters for everything else in this chapter. During the waking hours, the brain is accumulating. Every new experience, every encoded episode, every spatial geometry filed by the parahippocampal gyrus. Each of these requires synaptic changes. The connections between neurons that participate in encoding an experience are strengthened. Long-term potentiation, the process by which repeated or significant coactivation of synapses increases their efficiency, is the cellular mechanism of learning. Use a connection, and it becomes easier to use again. Encode a memory, and the synaptic weights that represent it increase. This cannot go on indefinitely. A system that only ever strengthened connections, that accumulated synaptic weight without any compensatory reduction, would eventually saturate. New learning would become impossible. Every new pattern would interfere with every existing one. The signal-to-noise ratio collapsing as the network filled up with reinforced but undifferentiated connections. The brain solves this problem through a process called synaptic homeostasis, a global downscaling of synaptic strength that occurs during sleep, reducing the overall level of synaptic potentiation while preserving the relative differences between strong connections and weak ones. The strong connections, the ones that represent consolidated, well-encoded memories, survive the downscaling. They were stronger to begin with, and after downscaling they are still stronger than their neighbours. The weak connections, the ones representing peripheral, redundant, or poorly encoded experiences, are reduced toward baseline. They don't disappear entirely, they just become too faint to reliably drive retrieval, which is functionally equivalent to forgetting. The molecular machinery involved is genuinely intricate, and I don't want to flatten it. But the broad outline is this. During slow-wave sleep, the sharp-wave ripples that drive memory replay also appear to drive a form of synaptic downscaling in the hippocampus, promoting long-term depression, the weakening of the underused connections, alongside the long-term potentiation of the replayed consolidated ones. Strengthening and weakening happening simultaneously, guided by the same oscillatory events, producing a net result that is more selective, more refined than either process alone would generate. The brain during sleep is not simply sussing, it is editing, and the editing is what makes the saved material useful. Here is where the immunology parallel enters, and I want to be careful with it. Not because it's wrong, but because biological parallels are easy to overextend, and this one has real limits. The immune system performs a function that is structurally similar to synaptic pruning in one specific respect. It clears debris. Dead cells, misfolded proteins, cellular fragments that would otherwise accumulate and interfere with normal tissue function. The immune system identifies these, tags them, and removes them through processes that are active, specific, and regulated. The clearance is not passive decay, it is targeted maintenance. Synaptic pruning during sleep has a similar character. Connections are not simply degrading from disuse, they are being actively reduced through molecular signaling cascades, through the activity of glial cells, through processes that identify underused synapses and systematically weaken them. The brain is not losing these connections, it is clearing them, making room, reducing interference, creating the conditions in which new encoding tomorrow will be clean rather than cluttered. The parallel is not perfect. The mechanisms are different, the timescales differ, the molecular players are distinct. But the functional logic that the system maintains itself through active clearance rather than passive preservation is genuinely shared. What this means for the familiarity system is concrete, not abstract. The Rhinal cortex holds representations of items and scenes, and the precision of those representations, the sharpness of their boundaries, the distinctiveness of their neural patterns, determines how cleanly the familiarity system operates. A perirenal cortex that has undergone proper synaptic homeostasis, where weak redundant connections have been cleared and strong consolidated ones reinforced, holds templates that are more distinct from each other. The pattern for room A doesn't bleed into the pattern for room B. The familiarity signal for a genuinely known face doesn't accidentally trigger for a merely similar one. A perirenal cortex that hasn't had adequate sleep, where homeostasis was incomplete, where the weak connections weren't properly cleared, where the templates remain slightly blurred at their edges, produces a noisier familiarity system. The boundaries between stored patterns are softer. Partial matches fire more easily. The threshold for generating a familiarity signal is lower, and the specificity of that signal is reduced. More false positives, more déjà vu, more moments when the recognition system says known and the recollection system says I have nothing. This is not a moral argument for sleep. Bodies are not moral. The biology doesn't care whether you sleep well. It simply performs differently depending on whether the maintenance is run. A well-maintained familiarity system catches its own errors more cleanly. That's all. There is something quietly interesting, and this is a personal observation offered without particular authority, about the fact that the brain's memory system requires periodic active forgetting in order to remember accurately. That the precision of recognition depends on the regular clearance of what didn't matter enough to keep. That the sharpness of the templates used in pattern matching is maintained not by accumulation but by selective reduction. It suggests that memory at its functional core is less about holding on than about letting go in the right ways. Less about the size of the archive than about the resolution of what the archive contains. A smaller, cleaner library outperforms a vast, cluttered one. Not always, not in every domain, but in the specific domain of pattern recognition, where the cost of a blurred template is a false match, and a false match surfaces as a feeling of having already lived something you are living for the first time. The synapses being cleared tonight are not precious. They are the day's static, the peripheral encodings, the redundant patterns. The experience is too similar to existing representations to warrant their own distinct neural real estate. Their removal is not loss, it is resolution. By morning, the templates will be slightly sharper, the boundaries slightly cleaner, the system slightly better at the particular task of knowing what it knows, which is, in the end, what all of this maintenance is for. Not memory for its own sake, not the preservation of experience as an end in itself, but the ongoing calibration of a system whose job is to tell the difference between old and new, to distinguish the genuinely familiar from the merely similar, to catch the false signal before it becomes a false belief, to surface the mismatch and flag it and let it resolve. The forgetting is part of that. The clearing is part of that. Tonight is part of that. Most people, when they imagine a perfect memory, imagine something enviable, total recall, every detail preserved, every afternoon retrievable in full, every face permanently filed, every conversation available on demand. The assumption tends to be that this would be better, that the ideal endpoint of memory is completeness, that forgetting is the bug and total retention would be the fix. There are people who live something close to this, not many. A few dozen documented cases worldwide studied under the clinical designation of highly superior autobiographical memory, HSAM. They can recall with extraordinary precision and verifiable accuracy what they were doing on essentially any date from their adolescence onward. Ask someone with HSAM what they were doing on a Tuesday afternoon 14 years ago, and they will tell you. The weather, what they ate, what was on television, how they felt, what happened next. Not approximately, specifically. They do not, by and large, describe this as a gift. The word that appears most frequently in accounts from people with HSAM is not lucky or remarkable or even useful. It is something closer to exhausting. The past does not recede for them. It remains equally present, equally vivid, equally demanding of attention. An ordinary afternoon from a decade ago carries the same retrieval weight as this morning. Nothing fades to the background. Nothing softens into the general texture of a life lived. Every day is available in full, and the accumulation of fully available days does not feel like richness so much as it feels like a room that never stops filling. Several people with HSAM have described difficulty being present, difficulty occupying the current moment without being pulled sideways into the past, which is always right there, always offering itself, never courteous enough to wait. The brain's selectivity, its willingness to blur peripheral details, to compress redundant experiences, to let the ordinary fade into generality, is not a compromise. It is for most people a form of mercy. The softening of the past is what allows the present to have weight. Memories that remain equally vivid regardless of how much time has passed are not more valuable than memories that have been edited by distance. They are differently burdensome. This is worth holding alongside everything the previous chapter said about forgetting as maintenance. The clearing of synaptic static during sleep is not only about precision, it is also about proportion, about ensuring that recent experience can be distinguished from old experience, that the near past doesn't get buried under the equally available far past, that the temporal structure of a life remains legible rather than collapsing into a single undifferentiated mass of equally present days. Memory was never designed for totality, it was designed for relevance, for keeping what matters approximately, with enough fidelity to be useful, and letting the rest degrade into general knowledge or nothing. The design is not elegant in every case. It produces false memories. It loses things worth keeping. It is vulnerable to distortion and suggestion, and the slow rewriting that comes with every retrieval. But it is a working design, one that most nervous systems have managed to use across an enormous range of environments to navigate a lifetime without being buried by it. Fatigue changes the parameters. A tired brain encodes less selectively. The mechanisms that tag some experiences as worth strengthening and others as dispensable become less discriminating. More experiences get treated as potentially relevant. More connections get partially potentiated. The consolidation process during sleep has more material to sort through and less precision with which to sort it. The result is not a richer memory. It is a blurrier one. Templates that should be distinct from each other share more overlap. Pattern matching thresholds drop, and the familiarity system, working from blurrier templates, generates more false signals. More moments when the recognition says known without legitimate cause. This is the biology of the fatigue déjà vu link, stripped of any romance. It is not that tiredness opens the mind to deeper perception. It is that tiredness reduces the precision of a system that depends on precision to function well. The déjà vu that comes more frequently after a run of poor nights is not a sign of heightened sensitivity. It is a sign of degraded calibration. Here is a detail that tends to surprise people. Older adults experience déjà vu less frequently than younger ones, considerably less, on average. The intuitive explanation would be that older memory systems are more error-prone, more likely to misfire, and should therefore produce more false familiarity signals. But the data runs the other way. Younger brains with their higher baseline levels of excitatory activity and more reactive frontal monitoring systems catch and surface more misfires. Older brains with slightly reduced excitatory tone and somewhat less reactive monitoring let more small inconsistencies pass without surfacing them to awareness. Less déjà vu does not mean fewer memory errors. It means fewer errors being caught, which is a distinction worth making even if it isn't entirely comfortable. The weight of an arm against a surface, something about the specific give of it, the way pressure distributes through soft tissue, unremarkable and constant and barely worth noticing. Akira O'Connor, whose fMRI work identified the frontal error monitoring regions as central to the déjà vu experience, noted something about this with directness I've always appreciated. When he was younger, he said, he had déjà vu frequently. Now, having spent nearly 2 decades studying the phenomenon, he has it considerably less. Not because he understands it better, because the monitoring system that was once vigorous enough to catch and surface small memory mismatches is, as with all monitoring systems, slightly less reactive than it used to be. He didn't frame this as loss exactly, more like a data point, something to note. What the brain does with memory across a lifetime is not a single consistent process. It changes. The encoding is more plastic in youth, the consolidation more efficient in well-rested middle age, the retrieval more dependent on cues and context as the hippocampal cortical transfer becomes less precise with time. The familiarity system runs hotter in young brains, catches more mismatches, surfaces more errors, runs quieter in older ones, lets more pass, produces fewer of those brief vertiginous moments when the present folds briefly over the past. Whether the quieter version is better or worse is not really a question the biology answers. It is just what happens. The brain at different ages is doing the same thing, maintaining calibration, editing what it holds, running its comparisons, occasionally generating a false signal and occasionally catching it, with slightly different precision, slightly different reactivity, slightly different results. The experience of déjà vu, wherever you find yourself on that continuum, is one marker of where the system is, not how broken it is, just where it is. The feeling lasts 2 seconds, sometimes less, occasionally 3. It arrives without announcement, carries its particular texture of wrongness over rightness, and then it resolves. The familiarity signal fading for lack of anything to sustain it. The room returning to being simply a room. The moment settling back into the present tense, where it belongs. No residue usually. No lasting confusion. Just a brief awareness that something unusual happened, and then the ordinary forward motion of a life resuming. That's the whole surface of it. But the biology underneath, the part that these chapters have been slowly turning over, is not simple. It involves 2 distinct memory systems running in parallel on different tissue. A para-rhinal cortex encoding familiarity as the progressive quieting of a response that was once loud. A hippocampus threading distributed fragments into coherent retrievable episodes. A parahippocampal gyrus maintaining an archive of spatial geometries accumulated across a lifetime of moving through rooms. A renal hippocampal network that occasionally falls into a brief miscommunication. The familiarity system asserting something the recollection system cannot verify. Frontal monitoring regions that catch the discrepancy and surface it briefly to conscious awareness. All of this for 2 seconds. The machinery is genuinely disproportionate to the experience it produces. Which is maybe one of the more honest things you can say about the brain in general, that its operations are almost always vastly more complex than the experiences they generate, and that the experiences are, in a sense, the simplified surface of something that would be unrecognizable if you could see it whole. What the research has made increasingly clear, and this is the part I find most worth carrying, is that déjà vu is not a symptom of something going wrong. It is a symptom of something going right, and briefly showing its work. The frontal regions that surface the mismatch to awareness are the same regions that prevent false memories from hardening into false beliefs. Their activity during déjà vu is not a sign of malfunction. It is error monitoring in action. Fact-checking, the brain running a quality control pass on its own output and flagging an inconsistency before it has time to settle into conviction. In a brain where this monitoring is less active, less reactive, less vigorous, the same misfiring would occur without surfacing. The familiarity signal would fire and nothing would catch it, and the false recognition would simply pass unremarked, absorbed into experience without generating any sensation of strangeness. The strangeness is the monitoring. The feeling of wrongness is the system working. I think about this sometimes when I'm tired and the day has been long, that particular quality of late-night thinking, where things seem more interesting than they probably are, and the distance between what the brain does and what the brain feels seems worth examining. There is something in the déjà vu experience understood fully that is oddly settling. Not because it's pleasant, it isn't especially just strange, but because it is one of the rare moments when the brain's maintenance operations become briefly perceptible, when you catch for 2 seconds a glimpse of the checking that runs continuously below awareness, flagging small errors, correcting small mismatches, keeping the memory system calibrated and honest. Most of that work is invisible. This particular piece of it occasionally isn't. The chapters before this one traced a long path through this biology, the hippocampus threading the day's experiences, the parahynal cortex encoding familiarity as the quieting of surprise, the parahippocampal gyrus holding spatial geometries, the rhinal hippocampal network generating the occasional false signal, the sharp wave ripples of slow wave sleep replaying and consolidating and editing what the day produced. It's a lot of tissue, a lot of mechanism, a lot of carefully evolved machinery whose ordinary operation produces, as an occasional byproduct, 2 seconds of sourceless certainty that dissolve before you can explain them. If you stayed through all of it, thank you for that. These videos exist because enough people find this kind of slow biological exploration worth their time in the dark, and that's not something I take for granted. If something in these chapters connected or settled something you'd half wondered about, pressing like costs nothing, and it tells me that this particular territory was worth covering. If you're new here and this is the first time you've found the channel, there's more, other systems, other quiet biological stories, all of it available, and none of it going anywhere. Subscribing just means the next one finds you without you having to look. The night is doing its work now. The sharp-wave ripples are running or nearly running. The hippocampus is replaying fragments of today in compressed electrical shorthand, the rooms, the conversations, the geometry of whatever spaces you moved through. Some of it will survive to morning, some of it will be cleared, reduced, dissolved back into the general statistical texture of a life's accumulated experience. The familiarity system will be slightly recalibrated by morning, the templates slightly sharper, the boundaries between stored patterns a little cleaner than they were at the start of today, and the next time that 2-second slip arrive, the room that feels already lived, the sentence that seems already said, you'll know if you want to know what is actually happening. The perihrenal cortex misfiring gently, the hippocampus failing to supply superior context, the frontal regions catching the inconsistency and surfacing it, a healthy brain briefly showing its work. Nothing more alarming than that, nothing less interesting. The members who keep this channel running, the ones who have made it a quiet, recurring part of how they end their nights, I think about them when I'm putting these together. Whether a chapter earns its length, whether the biology has been handled carefully enough, whether the thing that took weeks of research and drafting and revision lands in the dark the way it's supposed to land, that kind of ongoing support through membership, through super thanks when something particularly connected, is what makes the long form possible. The 2-hour version, the one that doesn't rush. So, if you've been here long enough to know what this channel is, you already know that. The feeling will pass. It always does. The brain resolves its small conflicts without asking for help, files the scene correctly, and moves on. By the time you've registered that something unusual happened, the machinery is already closed. The templates are being refined, the archive is being edited, and the checking, quiet, continuous, mostly invisible, is still running. It will be running when you wake. It runs all the time.